Hi, thanks for joining me today. I've got a super quick video for you. I saw this trick online, all to do with matrices and seeing if they're invertible or not really quickly. And I've not seen this before, so maybe this, it's pretty simple and pretty obvious once you look at it, but I'd never seen this trick before, so I thought I'd share it with you guys. So in this case, I've drawn up a 3x3 matrix, and we want to know if it's invertible. And of course, you could just put it in through, compute the determinant, the long weird looking formula where you look at this guy here, compute the determinant of this guy here, then you have your pluses and minuses and so on, or you can plug it into an online calculator or something like that. But that's going to take a while. However, I can tell you that this matrix is invertible and we can prove it in just a matter of seconds. So if you want to see or try and prove that this is invertible, this video is probably only going to be 2 or 3 minutes long. See if you can prove that it's invertible in just 2 or 3 minutes, and I'm going to get stuck into proving that this is indeed invertible. Okay, so the way that we're going to prove that this is invertible is essentially by looking at this matrix here and reducing it mod 2. So we're going to basically just consider the parities of each of the entries, because every entry here is an integer. So what we're going to do is just reduce it mod 2, so it's going to be equal to, or potentially congruent to I should write, 882 is even, so that's going to be 0, 734 is even, minus 19 is odd, 246 is even, 7 to the 7 is going to be odd, so that's 1, 6969 is just going to be 1, 421 is going to be 1 because that's odd, 0 is 0, and 1001 is odd. So this matrix here is congruent to this matrix here mod 2. Now if this guy here is invertible, then that certainly means that this guy here is invertible. And the way we're going to show that this is invertible is by considering the determinant of this, and we'll show that the determinant of this is not going to be 0, hence the determinant of this matrix here is not going to be even, it's going to be odd, and hence the determinant of this matrix here can't be 0. So the determinant of this guy here, well, we can just use our standard formula, use this guy here, 0 times the determinant of this guy, well that's just 0, 0 times the determinant of this guy, that's going to be 0, and then we're going to have to add on one lot of the determinant of this guy. So the determinant of this guy here is just 1 times the determinant of this guy here, which is 0 times 1, minus 1 times 1, which is just minus 1. 1 times minus 1 is minus 1, and hence in particular it's not going to be 0, and hence this guy here has determinant non-zero, and thus this guy is invertible. And that proves that this is invertible without doing much work. Now, of course, this works for other residues, so you don't have to look at this mod 2. Say if it was obvious that a lot of these are multiples of 3, then you might want to look at this mod 3, and provided this guy here is determinant non-zero, then that means this guy here has a non-zero determinant. But of course, it's kind of only a one-way thing. If we proved, say, if we changed this entry here to a 0, so this guy here has determinant 0, so this matrix here is not invertible. However, when we bring it back up to the natural numbers, this matrix here could potentially be invertible. So the only way that we can know for sure if this guy here is invertible is if this guy here is invertible. If this guy here is not invertible, that doesn't necessarily mean this guy here is not invertible. Anyway, I hope that all makes sense, and I thought I'd share this quick trick with you. Thanks for watching. I'll catch you in the next one. Have a great day.